Good morning, everyone, and welcome to our program about transatlantic developments in the semiconductor industry and how Europe and the US can work together more effectively. This event is organized by the European American Chamber of Commerce. My name is Yvonne Bendinger-Rothschild. I'm the Executive Director of the EACC in New York, and I will be your host for today's event. We have an amazing panel today, which includes Lucilla Scioli, the Director of Artificial Intelligence and Digital Industry at the European Commission, DG Connect, the Director General of the, which is responsible for investments in research, innovation, development of critical digital technologies. We also have Adam Schaefer. He is the head of supply chain strategy for the CHIPS Program Office at the US Department of Commerce. The organization is also called CHIPS for America and encompasses two offices, the CHIPS Research and Development Office, which is responsible for investing roughly $11 billion into developing the domestic R&D ecosystem, and the CHIPS Program Office, which is dedicating roughly $40 billion to provide incentives to facilities and equipment set up in the United States. We also have Avi Mesika calling in. He is the CEO and co-founder of Neologic, an Israeli fabless semiconductor production company on a mission to revolutionize high-intensity computing. Neologic developed the next generation processor that minimizes power and reduces the complexity of digital circuits, which helps deliver circuits that don't exist right now in the current technology standards. I'm absolutely convinced that he's going to revolutionize how we think about semiconductors and provide amazing solutions, especially in the space of cloud computing. Our moderator today is Lucinda Creighton. She's the CEO of Vulcan Consulting, a consultancy which specializes in European Union regulation, policymaking, and the political process. Lucinda is a former Irish government minister for European affairs, and she has extensive experience and insights on the decision-making process across Europe. And with that, is the perfect moderator for today's discussion on how Europe and the US are collaborating, and actually not only collaborating, but how they're tackling the dependency on foreign resources in the semiconductor industry. And since the pandemic and the invasion of Ukraine by Russia, the ecosystem has completely changed. Both Europe and the United States are eager to work together and leverage innovative ecosystems and to build up their position in the semiconductor ecosystem to avoid dependencies, or to counteract dependencies, I should say. And we have a specially created Trade and Technology Council that the two nations are trying to find effective, or utilizing to find effective ways to realign their strengths and rebuild a balanced semiconductor partnership with a trusted ally. And that will be, in a nutshell, the discussion that our panel is having today. And with that, I hand over to Lucinda.
Fantastic. Thank you, Yvonne. And it's a pleasure to be, well, I'm actually technically in New York. So it's nice to be in New York to chair this discussion on behalf of the European American Chamber of Commerce here in New York. And I'm really delighted that we have such an excellent panel. We really wanted to put together an informed discussion on what is really happening in Europe and the US, and to tease out the opportunities for greater collaboration in the context of all that is happening in geopolitics at the moment. This is, I think everybody can agree, semiconductors and chips have become, really very central to all that is happening globally, and Obviously, the weaknesses and risks in the supply chain were highlighted by Yvonne, but there's also huge opportunity, and obviously has been really rapid, I think, response and reaction in both Washington and Brussels in the last few years. So I think it'll be very interesting to try to understand that in greater depth in the hour that we have here today. So Yvonne has very helpfully introduced the panelists. So what I propose to do is to invite each of our panelists to speak for 3 or 4 minutes, just to sort of highlight their perspective on the topic of how the EU and US can advance together in this chip race, as it's been described, and maybe to give some insight into the changes that have already happened, both from the industry perspective and also from the policymaker perspective in the US and the EU. So I think I will kick off by inviting Lucilla Scioli to share her thoughts, and then Lucilla, when you've concluded, I'll move over to Adam, and then Avi third to give the industry perspective. So Lucilla, over to you.
Thanks a lot, Lucinda. Thanks a lot for inviting me to this event. So I am responsible for the policies of artificial intelligence and for semiconductors in the European Union. And in the European Union, we also, like in the United States, have a CHIPS Act. Now we've had the CHIPS Act for almost a couple of years. And the reason why we had a CHIPS Act is because of the excessive dependencies, as you said, that we have in our market, in particular for elements such as production of advanced chips, which is mostly taking place in a couple of countries in Asia, or we are very dependent on the design tools that are developed mostly, again, by 2 or 3 companies in the United States. We are also, dependent on other design elements. And it is not so much a dependency that is a problem. I think that the real problem is when you depend on a very limited number of companies in a very limited number of countries, because then any kind of disruption can be problematic. And of course, if you think that TSMC is located in Taiwan, that already gives an insight to the problems that could be created. But so with the CHIPS Act, the European Union wants to strengthen the resilience of its supply chain. It does not mean that the European Union wants to become self-sufficient in the design and manufacturing of chips. It only means that it wants to be able to diversify its sources, work in close cooperation with strategic partners, including with the United States. And it is almost a contradiction today. On the one hand, all governments, in the name of economic security, and are really strengthening their developments in semiconductors. On the other hand, these supply chains are really global. So I think it is impossible for any country to be self-sufficient, and therefore I think that any kind of strategic partnership, as they could be between European Union and the United States, and also other partners such as Japan, for example, is key to our future in the area of semiconductors.
Great, a super start. Adam, can I invite you to share your thoughts?
Yeah, of course. Thank you very much. Just open by thank you for including me on this panel, and thank you for inviting CHIPS to participate. I'll echo a lot of what was just said. I think it's goes without saying, or it's very obvious that semiconductors overall are integral to America's economic and national security. That is what we used to understand and justify the CHIPS Act and to appropriate the tremendous amount of money and as well as the policy that we're going forward with. And as was just said, many of the elements of semiconductor supply chain are geographically concentrated, and that in itself is not the problem. It does, though, predicate some vulnerabilities that I think are certainly that need to be taken seriously, and were certainly also driven home particularly in 2021, where there were a lot of supply chain shortages of semiconductors. Very much like what was just said, as we have stated publicly in many ways, is we also do not want to be completely self-sufficient in semiconductor production, but we're looking to work closely with our allies and partners, like the EU, and as well as around the globe, to build together a healthier global semiconductor ecosystem and be able to move that supply chain resilience question forward, so that we can say we are not solving all the problems, but we are continuing to improve, and we're continuing to be aware, and we're working on the hardest problems that we can in the most cooperative way. So that's really where we're coming from. Certainly getting above and beyond the make an investment, build a fab. It really is that entire value chain, as was just said in our perspective as well.
Mm-hmm. Great. Avi.
Yeah, okay, I'll add the perspective of small companies and startup companies. First and foremost, semiconductors design as well as manufacturing is capital intensive. And I think that for companies on both sides of the ocean, in terms of getting the funds, even though there is a renaissance, I think in the, let's say, 4 to 5 years, still there is I would say some sort of a market failure in terms of funding these companies. The CHIP Acts, at least to my taste, on both sides, and as Adam said, are mostly focused on production capacity and less, I would say, about innovation. I think we are familiar with the American CHIPS Act because we are part of the team of companies that wrote the RFI. We are, I think, instrumental in writing the advanced logic chapter of it. I think it's not well balanced, and I think if we are looking for, say, some sort of collaboration, the innovation aspect should not be ignored. Because currently it's almost overlooked. I think that in the US, and also there is an issue, I think, which is important, at least for the issue of production capacity, is the education and getting the entire, in fact, in the US, and excuse me if I'm more focused on the US, but also in Europe. The ecosystem currently does not support, I think, the challenge of setting up advanced leading nodes for production in the US. I know, for example, that TSMC, for their fab in Arizona, had to relocate Taiwanese engineers because of a lack of sufficient and proficient engineering forces in the US. So it's not just about pouring money. I think that pouring money alone will not deliver what it is expected. It's about building or rebuilding the ecosystem that both sides of the oceans have kind of lost in the past 30 years or so. And this is also a point for collaboration, which should be taken into account.
Brilliant. So I think that's possibly a good place to kick off our discussion, because I think it would be helpful to understand the sort of strategic objectives from both the US and the European perspective. So Avi, you've talked about the need to not overlook the innovation aspect, and I think we've heard in discussions of the CHIPS Act in both the US and Europe that is very much an ambition. So maybe Lucia, you might talk a little bit about how Europe hopes to address that. You know, what is, because everybody's talking about state subsidies in Europe, you know, so everybody's looking at, well, you know, which government is gonna invest the most in Intel, TSMC or whatever. So how do you sort of view the research and innovation aspect of this? And how important is it from the European Commission's perspective?
Well, I think there are two elements to take into account here. The first one is we, like Adam, I think, anticipated for the United States, we have a research and innovation program, which we co-fund with the member states at about, if I'm not wrong, I think it gets to 11 billion euros. And so through this research and innovation program, we do both research and development, but also the development of a sort of infrastructure that we want to take place in Europe to facilitate the fact that research outcomes are then translated into industrial advances. This is for the European Union, you know, one of the main issues is that we have very strong research and technology organizations, but there is almost like a gap where before being able to bring the research outcomes into the industrial uptake and industrial further development. So, of course, we are very strong in certain segments. I'm not saying this happens in all the segments. We are very strong in equipment manufacturing, for example, with ASML and these very strong European companies. But in many other areas, in manufacturing, for example, we have a gap. And so we hope that by developing pilot lines and capabilities also to test and experiment designs in advanced semiconductors, we can a little bit give incentives, not only for the manufacturing, but also for the design part of the ecosystem. And we're also going to set up a design platform to allow startups to come in and receive support in the way they can deal with the design tool providers, which are also a kind of concentrated segment, and also helping them financially for their first tape outs. So because maybe differently from the United States and the European Union, we're also a little bit weak from the design side. So we have a program, yes, on manufacturing, but also with the idea of reconstituting the ecosystem, including on the design side. But on the manufacturing, so a separate activity is to support investment in the European Union in manufacturing. And here it's not just any manufacturing. Here we really pay attention that public support is given to activities that are considered to be first of the kind in the European Union. So support can go, of course, also to a fab manufacturing a mature chip, but that mature chip will have to have some innovative characteristics that will make it a first of a kind in the European Union. And we do that also from the point of view of the process technology. So we always, in this particular case, to make sure that the process technology is particularly environmentally friendly. And so all these approaches are going to bring innovation also on the manufacturing side.
Okay, very good. Adam, from your perspective, again, in the US, I mean, a huge amount of focus has been on reshoring, you know, supporting investment in manufacturing in the US. Is that an old-fashioned way of looking at this? I mean, or will it complement the ambition on the innovation side? What's your thinking?
Yeah, I think Lucia really did a great job of talking about this and looking at this is a very large equation across the entire value chain. And my title says supply chain, but really even getting to the point of building out the silicon and semiconductor, that's still the middle of the supply chain. It's still not getting to the consumer. So I think the way I look at this is, the analogy I would say is, it's sort of like picking your favorite philanthropic purpose. There is no bad one. Whatever you think is important, whatever I think is important, whatever our neighbor thinks are important, they're all good causes. And so I think the analogy works in that there is room for innovation across lots of spectrum. There's room for innovation in cost. There's room for innovation in environmental sustainability. There's room in innovation between those two. If you look at driving circularity for environmental purposes, to lower cost, to improve supply chain resilience, to improve the control of hazardous materials, for example, all of that can be a win-win-win, but it takes energy, effort, and engineering support. It doesn't necessarily immediately translate to, as Avi was saying, the leading edge generation, next generation patterning, or next generation product design, but that doesn't make it less important. So I think that the way I look at it is, you need to do all of these things in parallel in order to drive operations to be successful in manufacturing, in volume manufacturing, in meeting the world's demand for current mature technologies and for leading edge technologies, as well as being able to say, what are the applicable innovations that are going to help different parts of that value chain, not necessarily with judgment on, is it really just the bleeding edge, but the judgment is this really going to be able to, as Lucia mentioned, be able to be taken up by the industry in order to move production forward. So that's really the way I look at it. Is it is complicated. There's lots of good. There's really kind of no bad ideas to start, but we also need to say, our R&D function has a critical role to play, and to be able to take those risks with smaller companies and with higher risk projects. At the same time, we're looking at doing what we've been doing for years, but doing it better, doing it smarter, doing it more sustainably.
And just on the point around smaller companies and startups and so on, how does the US CHIPS Act support them in that process, or bring them into that process?
So I think, as was mentioned in the introduction, there's really two parts of the US CHIPS Act. There's the $39 billion that was designated as part of our grant function, and that started quickly, and many very globally public announcements have come out. We've already given away significantly more than half of that money, or pledged. We haven't actually given it away, but pledged more than half that money, mostly to leading edge manufacturing. But there'll be more down the line through to current and mature, more memory, and then a lot of different supply chain companies, some of which are smaller. But most of that is to support manufacturing. It's to support, how do we onshore, as you mentioned, how do we onshore that capability? Where we're going to be able to take more risks and where we're going to be able to make additional investments is the other part of CHIPS, which has been designated as $11 billion. It'll be called the National Semiconductor Technology Center, and there's a NAM, National Advanced Packaging effort as well. And those two efforts will have a significant funding to drive research and development, to work with academics, to work with industry, to work with other, a very important partnership is to work with existing consortia and globally, to be able to say, hey, what are those key problems that we can both move forward as well as affect change to improve those the performance and the across those value chains. So that R&D programs, that's where we're going to have that engagement.
Okay. And Avi, I mean, I detected from your introductory remarks a certain degree of concern that that sort of benefit is not, at least not yet, being felt by smaller startup companies in this business. Have you a view on what's coming down the line. You know, probably it's a phased approach. Everything's not going to happen all at once. Are you hopeful that that you know there will be a place for companies like your own and others, you know, through both the US and the European CHIPS Acts?
Well, obviously, my point of view is narrower than Adam and Lucila. I see it through very, I would say, narrow view. I think that currently most, and I'm talking about technological innovation, not even though all the innovation aspects that were mentioned by Adam are important to my mind as well. But I'm looking through the eye of technological innovation, and I don't think that there is enough incentive, at least as I'm familiar with the American CHIPS Act, for technological innovation. I know, yes, there is something a little bit within, I mean, in the National Semiconductors Technology Center budget. So far, I mean, as I talk about with respect to my company, we've been sitting on the fence, waiting to see how things roll out. Currently, what we see is that most of it goes to manufacturing. We get on a routine basis the calls from the DOC. I think, well, at least as I see it, and also with respect to AI compute, most of the funding to date comes from venture capital funds. The vast majority of it comes from venture capital funds, and as little place within the American CHIPS Act. I think in Europe, as we know it, within, say, the New Horizon program, there is more allocation of funding to technological innovation, and I think it goes together. I mean, to my mind, it's a mistake to consider manufacturing, building a manufacturing capacity, especially the gap is in the advanced technology nodes, not in the old mature ones. So to build an advanced manufacturing in the advanced technology nodes, it might fail without really pure technological innovation. This is my concern about it. So far, we've been sitting on the fence. We haven't applied for any grant from the CHIPS Act. None of them that we received has met. We didn't fit, and in one aspect, and in other aspect, didn't fit to what we can do. There are some I think money that has been allocated for defense, but that poses a different hurdle for commercially, because you need a dual use, and you not necessarily want to get into that. So I think really, I mean, to the best of my knowledge, again, and you should take my view with a grain of salt, there isn't much room within the American CHIPS Act for really pure technological innovation. And that's a pity, because I think it misses the point. Companies such as Intel has gotten the most of the cake, and I'm not sure that it will deliver.
Okay.
But that's my view.
Yeah, interesting. I'm sure, Adam, you probably want to
and obviously, if we're looking for the next step, if we're looking for the next step, I think we should take that into account. I mean, especially if we are collaborating, there should be more emphasis on pure technological innovation. This is the only way, at least to my mind, to close the gap.
Yeah, maybe I'll just if you don't mind, Avi, I think this is why I use that philanthropic model, because you're 100% right, and because there are lots of ways that we need to continue to invest, and I don't think by design, I don't think we've done that yet, right? The emphasis was very much, for a lot of different reasons, to bring that manufacturing prowess forward and bring it to the U.S. And I agree with you completely that just pouring money into a company is not a guarantee of success. Whether or not that's pouring money into a company that has, just because you have a track record of success, there's a lot of skills at those companies. Full disclosure, I worked at Intel for 22 years before joining Department of Commerce. And or to other companies who have been successful, and are they going to be successful ramping those technologies on the other side of the world? I deeply intimate with the challenges of building the most complicated products in the world and then trying to build them again across the ocean, whether you're in Kiryat Gat or Ireland or China or the US. Those are hard problems. Those are hard things to do, and they're worth putting this effort into. That takes nothing away from what your point there of saying driving those additional technical innovations, and whether those innovations are in product design, in transistor design, in light sources for EUV, in raw mineral sourcing, in chemical safety. That's my point, is all of these do tend to be important. And I think maybe just to close on that, I think one of the things is the responsibility for a program like ours is to continue to communicate that we're not done. We have a long way to go. You are right that much of the announced fundings has gone to existing manufacturers. But we do have a long way to go, and the R&D effort is behind the grants effort. Again, this is by design, although I think we all want to move more quickly. And we need to be responsive. We need to be responsive to different parts of that value chain, and so that we can drive innovation. We're not going to solve all the problems, and we're going to need to take risks. And we need to partner, I would say, as well. So if the money is coming from venture capital, what are the needs of that community to say, hey, is there some sort of force multiplier that a CHIPS program can do by, maybe it's a grant, maybe it's direct funding, maybe it's partnership, maybe it's a facilitization, maybe it's an endorsement, maybe it's partnership with those venture capitalists as well. And so those relationships, I think, are continuing to be built, and they continue to be important for success where we can find it, and for failures we can learn from where we find those as well. And I think that's very much in line with the long-term vision.
Okay. We're halfway through, and I have a few questions here from members of our audience. One is about the technology itself. So, Avi, you mentioned next generation chips. Currently, the smallest geometrics have been achieved by TSMC. So how do you see the shrinking geometries? Will there be a focus on using new materials, moving to photons instead of electrons? What's the kind of what's the trend or the likelihood of those sort of changes and innovations? That's a question for you. Another question, there are chip manufacturers, chip designers, equipment manufacturers, right down the supply chain, so, and they all require funding too. So how do you see that? It's probably a question for Lucilla and Adam. How do you see that cascading down? Is it going to be just a natural process? Will it be targeted by the European Union, by the US administration? How's that going to work? So I don't know, Avi, do you want to answer the first question?
Okay, I'll address the first one. It's a good question, by the way. I mean, if we want to close the gap, the West in general, with respect to the advanced technology nodes that are currently dominating, 90% of them is manufactured in the West. First and foremost, I do not dismiss other technologies, but I think silicon will stay probably for the next 2 decades or 3 decades as the leading technology of digital computation. I don't see any other rival, and I've been there for the past 30 years or so. It's not that photonics won't have a niche application, or I don't know. People talk about quantum computing. I'm doubting about that, but maybe sometime graphene and all these kinds of exotic materials might find niche applications, but the main platform for designing and manufacturing processors will be still silicon-based. Even for the plain reason that trillions of dollars have been invested in manufacturing facilities, nobody is going to scrap them. So that said, now the question is, how do we move forward? Because transistors cannot be shrunk anymore. Today, we don't shrink transistors. 10 nanometer transistors are 20 atom size. That's, I would say, astonishing in terms of, imagine that mankind succeeds to tailor or manufacture things that are of the atom size. There's no such equivalent in any other sector. So we have come to a point that we can't do that anymore. So currently what we are doing is shrinking the environment, the cell size, what is called the standard cells that surrounds these transistors. Now, we are also approaching a wall in these terms. 2 nanometer is now kind of a wall. We're hitting a wall. So this calls, I think, and this is an opportunity for the EU as well as the US to explore different, if you'd like, frontiers of compute. And again, to my, I'm sorry to say that at this point, I don't see that. This is unfortunate. So I think that technologically wise, and if we want to close this gap and maybe even leap ahead, we need to put and it's not necessarily only advanced logic. It's not only my domain. I think analog computing, especially if we talk about AI, and also memory. We need to invest. I don't know, I would expect that 10% of the CHIPS Act to go to innovation, risky innovation, that we know that most of it might go down the toilet, but if a fraction of it will succeed, we will be able to leap forward. And this, by the way, it's not just gaining an edge over the East, it's for the entire mankind, because we have a problem in compute now, right now. So that's my take on it.
Mm-hmm. Thank you. Lucilla, did you want to address the other question? Just about the sort of the focus or investment down the supply chain?
Well, I think that governments fund where they see that in their markets there is a market failure, or for economic security reasons, for example. So the funding can go to manufacturers as well as it can go to the designers or to the equipment providers. Now, the cost can be very different in the sense that everything is costly. Also, the design is costly, but the size of the cost is a little bit different, because to build a factory, I mean, we are talking of very, very expensive factories, and they are very intensive also in R&D. This is why I think governments tend to put more money in manufacturing activities than in the design activities. The design activities can also be very costly, in particular for the design of the advanced chips, but the costs are not comparable yet. So I think governments may have reasons to fund all the different sides.
Mm-hmm. Adam, any thoughts on that, or?
Yeah, I mean, I'll be very, maybe a little more concrete. Is for the grants program that we have, we had our first notice of funding opportunity. That's the formal program for manufacturers to apply for funds for their projects. We also had a second notice of funding opportunity. We just sent out our next round of invites for those, and that was focused on supply chain projects less than $300 million in capital. That's a big part of my job is driving that. So we had specific efforts. Now, whether or not those are equipment, as the question was asked, it really is across the gamut. Whether it's equipment, subcomponents, chems and gases, raw materials, facilitization, as long as it was manufacturing according to the statute, it was eligible, and we'll be putting $500 million into that specific effort. There are other projects within the supply chain, again, in those categories, with packaging facilities, materials, et cetera, in part of the first notice of funding opportunity, because they were larger projects. And we take each one of those seriously and on their merits, and you'll be able to see some successes and investments in that supply chain. But as we look at that full equation from the fab upstream and maybe downstream into advanced packaging and toward the ultimately towards a consumer, we're not going to be able to fund every node in that equation, and we're not being asked to. Though not every company has applied for funding, but we do believe, again, in that purpose of improving the supply chain resilience, and as well as supporting those fabs, that there will be an impact and an effect across those covered companies, as well as companies that, because of the statute, we are not able to support, but continue to remain critical to the overall success and supply chain for semi-manufacturing.
Very interesting. Okay, maybe just to pivot for a moment, I think we're almost 3/4 of the way through, and nobody has mentioned China, which I think is it's just interesting. It's sort of the elephant in the room, and I mean, obviously there was a lot of attention last year when when Huawei launched the Mate 60 Pro, and the focus obviously in the West has been on sort of de-risking from China, decoupling, depending on your perspective. But it's also sort of happening in the opposite direction, isn't it? With China trying to reduce its dependency on Western technologies. Do you see that as a threat, a cause for concern? Are you seeing any reaction from US chip makers, in terms of their position, supplying China with the tools and the necessary capabilities to produce indigenous Chinese chips? I don't know who'd like to take that one. Adam?
I'll talk about it a little bit very, very quickly. I think there's been some very high profile impacts on for existing manufacturers as they're driving and moving their supply chains. I think from an upstream standpoint, it really is an and versus an or. We're seeing more of additional supply being planned and announced, as opposed to necessarily removing. And again, that's an improvement, not a solution to a constraint. And then the other piece too, as we look at the overall economic and national security impacts for the U.S., Europe, and allied countries, and to Avi's point earlier about current and mature technologies, is really being able to assure that there isn't a undermining of the global supply that happens as those supplies ramp up for their domestic consumption as well as internationally. So I think those are the ways we're looking at those changes. So not necessarily an abrupt process, but more of an evolution to meet demands and to lower those risks.
Very good. Avi, you looked like you wanted to come in there.
I think I'll put it very simply. I think we have also in this aspect in semiconductors a polarized world where and let's talk even about China as a whole. The East is as the upper end in terms of manufacturing, and the West as the upper end in terms of chip design. Now, what I see is that, and I think that the banning of China from access to different technology. Now, each party, but each side tries to close the gap on its deficiency. I mean, the US tries to build a production capacity in advanced nodes, and China tries to close the gap in chip design technologies. But also China, mainland China, tries to close the gap in terms of advanced manufacturing. And I think that what has been going on in the past 5 years or so has been counterproductive from let's say from our side, I mean the West side, because it just catalyzed and accelerated China, and it has closed the gaps in many aspects. Mainland China, SMIC now is piloting 5 nanometer technology, which they didn't have. Well, no, I'm not talking about TSMC. We're talking about mainland China. This is a leading edge that even the US doesn't have. And this has happened on the course of the past 3 years. They are closing the gap in advanced design technologies. So I really don't know what's going on. I can tell you that the Chinese are very aggressive. We've been approached by at least 3 Chinese companies, and they were willing to open subsidiaries in Hong Kong for the benefit of working with us. On the other side of the ocean, we know that leading American companies do sell. I mean, we don't do that because we are not allowed in, even you know, by the US export rules, but leading American companies bypass these and do sell. So I really don't know what's. I think we are shooting our own leg on this. We have caused them to accelerate the advancement in both manufacturing and chip design. I'm not bullish about our success, as you probably felt, but never mind.
Lucilla, I want to. We've less than 15 minutes left, and I want to get on to some discussion of the opportunity for potential cooperation between Europe and the US. But just before that, maybe on the China question. I mean, I think Europe has been criticized in the past for being a little bit naive when it comes to China and its intent in Europe, but that's beginning to change. I think we've seen some pretty dramatic events even in the past week or so in terms of how certain Chinese operations in Europe have been handled by the German authorities, by the European Commission and others. So it's heating up. Do you share Avi's concern about China closing the gap from the point of view of both design and advanced manufacturing? Is this something that drives you and your team in the Commission, or is it something that you're sort of not too exercised about?
Oh no, we discuss a lot about this. It's not only about China, it's also about other parts of the world, but of course the position of the European Union vis-a-vis China has been maybe less radical than the position of the United States. We've always talked about a third European way, and but still the export controls of the United States have an impact also on European companies. So the issue is very relevant for us as well. And I was listening to the positions of Adam and Avi, and these are exactly what you would hear in Europe when you hear government talk and what you hear the companies talk. So I would argue that it is a good idea to try to delay the acquisition of capabilities by the Chinese in particular, because with those very advanced chips, they could advance very quickly also in areas like artificial intelligence. So I see the point of the export controls. Many companies in the European Union would rather argue that instead it just delaying of a few years that China has the capabilities to develop advanced chips and even in the presence of the export controls. And this example that you gave of the Huawei phone earlier, I mean, it's just an example of that. So I think we have exactly the same kind of conversations. The difference between the European Union and the United States is that the European Union does not have, for the moment, we don't have the competence on export controls, so the competence remains with individual member states. And we are now discussing all together to see whether we can bring about a change, because of course, sometimes you have an export control would have an impact on a country, the country would react, but then there are other member states that get impacted because companies have suppliers and so on. And so any of these issues becomes necessarily bigger than a single European member state, and it becomes a European issue. But just to say that this kind of different viewpoints we have heard from Adam and Avi, we have exactly the same kind of reflections in the European Union.
Yeah. So I mean, that brings me neatly, I think, to the next and probably our final topic, which is, what is the state of play in terms of coordination, cooperation, collaboration between Europe and the United States in trying to meet this challenge? And I suppose maybe to kick that off, one of the questions earlier was about the kind of brain drain from the industry, the insufficient numbers of PhDs, engineers available to really drive this innovation that we're all seeking and talking about. And I think it would be useful to hear from you whether that's an area where we can see greater collaboration across the Atlantic, and what other areas, and how best to achieve it. We've talked about the TTC at the beginning, but I think well, it depends who you speak to, but certainly there is a view out there that it has been underwhelming in what it has delivered in terms of transatlantic cooperation. So who'd like to tackle some of those points? Avi, I think you probably have some ideas or thoughts on.
I'm not sure that I'm the qualified person to address this question, but I think just a fact: the Taiwanese government has allocated, on average, $1 billion per year for the next decade for talent education, from the technician level up to the PhD level. So this is because currently there are roughly 25,000 positions that are unmanned in the Taiwanese semiconductor industry. I mean, I don't see, and again, I'm so sorry that I sound judgmental, because I'm not. It's painful for me to see that we don't react to that. I think in the chip sector there are only $200 million that were allocated for that, and that's really a meager amount for the amount of fabrication facility that the US wants to set up in the US. So this is definitely a point of I think collaboration.
Mm-hmm. Yeah, Lucilla.
Yeah, if I may. It is true that we both have the same problem, that we have the shortage. So I don't know how much we can help each other, given that we both experience the shortage. But I also don't think it's just a matter of money. I think that in the European Union, for example, there is an issue with how attractive it is to work in the semiconductor industry. I mean, younger people are more attracted to work in AI than to work in semiconductors. And I think we miss the capability of presenting this area as a really attractive area to work in when the engineers are making the choice between working and doing electronics or doing something else. And then in the European Union, we have the huge problem of the female participation. Here, I really have to say that really the semiconductor discussion is fully male dominated, and we have a lot of difficulties in bringing ladies also to undertake this kind of studies. So that's when maybe the money could help if there were scholarships maybe dedicated to this, but otherwise, in my opinion, the solution has to be, on the one hand, in finding ways to making this kind of studies and this kind of industry more attractive to the young people. And on the other hand, also creating networks between universities and companies, and making sure that students have the possibility to spend some time in companies, because then they may stay there or they may be recruited there once they finish their studies. And so you really create a close connection between the university and the industry. There would be the possibility of on-the-job learning. So it offers so many possibilities. And I find that in the European Union, this close collaboration is limited.
Mm-hmm. That's a very important point, and that sort of collaboration. I think we've seen a lot of success in the pharmaceutical and life sciences area, where there has been certainly in parts of Europe, I think really excellent collaboration and design of programs, cooperatives, work placements, etc. All part of the both undergraduate and postgraduate programs. So I guess we need to see a lot more of that. Adam.
Yeah, I couldn't have said it better. I think actually you really hit it on the head in terms of there's a lot of factors to this. Some of which is continue to make it more attractive, is to really make sure that we are driving diversity, not necessarily for the wonderfulness of diversity, which I'm a strong believer in, but also to continue to tap those areas of talent and intellectual diversity and different backgrounds, and being able to again look across the world for that skilled talent and compete. These are factory jobs. There's a lot of jobs that need to be in the factory, and maybe so I think you said it beautifully. One thing I will add, though, is that there's this question of volume. I think we need to continue to drive that innovation. We also need to make a lot of stuff. We need to make a lot of stuff in order to meet these demands. The global demand is not going anywhere, and whether there's ebbs and flows on exactly when that lands, I think the world is fairly aligned that it will be there in the next 10 years. And maybe just one point that hasn't been brought up is we also need management. We need managers. We need the people who are in those factories today, the 25 to 35-year-old young engineers who are working very hard to drive the innovation at Intel, TSMC, Samsung, Micron, SK, all those wonderful companies, to be ready to be the leaders of this incoming influx of people we need, so that not only can we work to attract them, but we can keep them there and give them the right leadership and continue to build those sustainable businesses long term. So that's part of what we do in our programs, is to have those workforce development engagements with each of the big projects and the big companies across that, whether it's education programs and those investments, all the way through to on-the-job training for technology and leadership capabilities.
Mm-hmm. Before we wrap up, can I ask you also to just comment on how and maybe where the opportunity exists for greater transatlantic cooperation on semiconductors? Is it through the TTC? Are there other ways?
We do have an international in the CHIPS office. We do have an international office led by Francis Chang, and we have engagements all the time with different the individual member states or with the EU, and we continue to try to build on what Tia opened with, which is really what are the relative strengths. So where are those strengths, getting down to the specific technologies, whether they're manufacturing, supply chain, compound semi versus silicon, all these different things, and really try to make those drive that understanding, so that we can look at the opportunities that are suited for us and look at the opportunities that may be suited for other geographies, and continue to work together in that overall allied ecosystem.
Great. Lucilla or Avi, any final comment on that?
Well, just to say that I wouldn't discount the TTC. I think that people say, yeah, but what have they achieved? Well, since the start of the TTC, we have a much deeper relationship between us. For example, we can call each other if there is a disruption, and I can tell you that this has happened. Maybe it's not in the news, but it has happened. We tell each other about the subsidies that we give. So we try to take care of subsidy races. So I think these elements are very important. And now we are looking at working together, for example, on PFAS. We want to be able to, to strengthen our research capabilities and do that together. So who knows whether, our researchers, by working together, can actually advance more than they have done until now. So I think we are looking at things. I don't know what people out there are expecting, but the simple fact that we have a direct line is also a very important element to take into account.
Thank you. Avi, the final word, and then I'll hand back to Yvonne to wrap up. Thank you. Oh, Avi, you're on mute.
Oh, no, I have nothing to add.
Okay, great. We're right on time. So Yvonne, thank you. Thank you for the opportunity to moderate this really interesting session. I think we've covered a lot. There's a lot more to say, but hopefully we may come back for round 2 at some point.
Yeah, and next time in person, and maybe in Tel Aviv, as we just said discussed with Avi. I mean, what I heard is, education and the challenges to find designers and engineers to deliver the innovation for tomorrow. I wonder if we can even wait for that. I mean, I like the suggestion to collaborate closer on a university level. I think that's definitely needed. And but I'm wondering how we can make the funding more borderless. And maybe joint research is a good start. I don't know. I'm just throwing this out there, because everybody is like, I give you, and you hear that all the time, Avi, I'm sure. I give you money if you move your company to the US. I give you money if you move your company to Europe. Fact is, Avi's company is in Israel, and how can we make it work for him, to collaborate either with Europeans or with Americans? And it doesn't really matter where we are. I mean, we need to work on this together. And I don't know. I'm just I don't want to start preaching, but I guess everybody hears what I'm saying. We need to be a little bit more open with funding these opportunities as well, because the future is now. I mean, we can't wait another 10 years until we have the next chip manufacturers educated, or until we have the next round of materials designed or discovered to make all of this happen. But like you said, Lucinda, this is a story to be continued. And thank you to the panel. Thank you to you, Lucinda, for moderating. I think this was a super interesting discussion, and I'm very curious to see how all of this is developing, how Adam, how your work is, shaping what's happening in the U.S. Uchila, how your work is shaping the European semiconductor industry, and obviously how you're making out, if you're going to start a revolution. I think you are. Again, thank you for sharing your insights. Thank you to our audience for joining us. And we have a couple of events coming up that are really interesting. May 9th, cybersecurity risks. On May 14th, the CBAM regulation out of the EU. May 20th, our EU economic update. And on June 5th, how AI is shaping life after death. Also going to be a really interesting discussion. We're going to post the webinar, the recording of the webinar on our website and on our YouTube channel. And we look forward to seeing you at our next event. Thank you, everybody.
Have a nice day. Bye-bye.
You
Have a
too.
good one.
Ciao.
Bye.
Thank you. Appreciate it.